Welcome to PV Installation and Operations. In this module, we explore how solar PV systems are installed, operated, and maintained, covering both grid-connected and off-grid applications. This session is essential for technicians, installers, EPC teams, engineers, and anyone aspiring to work in solar project execution. By the end of this lesson, you will understand different categories of DRE systems, all common PV system components, how to design standalone systems, how to size and plan a solar mini-grid, how to select high-quality components, how to correctly size cables, critical safety features, and the best practices to ensure successful installation. Decentralized renewable energy, or DRE systems, bring clean power solutions to places where traditional grid access is limited or unreliable, especially rural and remote areas. Professionals working with DRE systems must understand components of solar systems, installation practices, safety measures, lessons learned from past project deployments. This knowledge ensures that installations are reliable, safe, and capable of meeting local energy needs. Whether it is a rooftop PV plant, a utility-scale solar park, or a solar mini-grid, all PV systems share a basic architecture. Let's understand each component and its purpose. Solar modules convert sunlight to DC electricity through the photovoltaic effect. Inverters convert DC to AC electricity for household and grid usage. Mounting structures maintain correct orientation and tilt and ensure mechanical safety. Meters, energy and net meters, track generation and consumption. Earthing infrastructure protects equipment and personnel from electrical faults. Lightning protection system provides a safe discharge path for lightning. Cables carry power across DC and AC sides. Connectors ensure safe, weatherproof interconnections. DCDB and ACDB protect and manage power flows on the DC and AC sides. Interconnection components enable safe grid integration. Data monitoring allows real-time performance tracking. Additional components for ground-based systems: evacuation switchgear, main control room, CCTV and compound wall, access roads, module washing system, drainage and water harvesting. Additional components for off-grid/mini-grids: battery storage, charge controller, off-grid inverter, local distribution network. Off-grid systems require careful planning because they must operate independently without grid backup. Key steps in design: load estimation. Identify all appliances. Calculate daily energy consumption. Separate day load versus night load. Solar resource assessment. Use location-specific irradiation data to determine available sunlight. Losses and shading account for temperature losses, cable losses, dust and module mismatch. Partial shading, DC or AC system decision. DC-only systems eliminate inverter losses. AC systems require an off-grid inverter. Battery sizing. Battery capacity depends on daily energy requirement, days of autonomy, system voltage, depth of discharge. A solar mini-grid powers multiple households or businesses. It requires careful planning of generation, storage, and distribution. Key steps: assess total load, add consumption of all users, calculate energy demand, understand user behavior and peak load timing, consider solar irradiation. Local insolation affects module sizing. Size components. Select PV modules, batteries, autonomy, inverters, charge regulators. Secondary energy sources. Include generators or wind where needed for reliability. Cable routing. Optimize to minimize voltage drop and losses. Protection devices. MCB, MCCB, fuses, isolators, and lightning protection. Metering and billing. Install meters for transparent, reliable billing. Selecting the right components ensures high performance and long-term safety. Let's review the key selection criteria. PV module selection. Consider orientation toward equator, optimal tilt, annual tilt approximately equals latitude, winter tilt equals latitude plus 15 degrees, summer tilt equals latitude minus 10 degrees. Degradation rates, shadow impacts, regular cleaning requirements. Inverter selection. Check. IEC certifications, manufacturer experience, ISO certified processes, warranty and extended warranty options, local service center availability, remote monitoring features, PV array inverter matching, match, PV string voltage to MPPT voltage window, PV current to inverter input current, PV array power to inverter rating. Mounting structure selection. Consider thermal expansion, corrosion resistance, wind load ratings, snow/ice accumulation, structural compliance, manufacturer mounting guidelines. Balance of system components include DC-AC cables, junction boxes, overcurrent protection, disconnect switches, surge protection, earthing and bonding, energy meters, monitoring devices, safety signage. Correct cable sizing ensures minimal energy loss, safe current carrying, avoidance of overheating, compliance with voltage drop limits. Considerations: cable length, current rating, voltage drop limits, conductor material, copper or aluminum, cable routing method, underground, tray, conduit. Cable sizing tools simplify calculation by considering conductor resistance, system voltage, load current, distance between components. Safety is fundamental to PV system design and installation. Let's break down the key protections. Electric shock protection. Installation voltages limited to is less than or equal to 1000 volts DC on buildings. Overcurrent protection required when multiple strings in parallel, battery systems, external energy sources, use of MCB, MCCB, fuses. Lightning and overvoltage protection includes External Lightning Protection System, LPS. Down conductors, earth terminations. Internal surge protection, SPD Class 2. Earthing system, 3 separate earthing types. Bonding earthing, equalizes potential. Protective earthing, fault current path. Functional earthing, equipment operation. Quality installation is the foundation for long-term system performance. Let's cover best practices across all installation areas. PV module installation. Correct clamp positioning. Proper torque applied to bolts. Avoid module deformities. Maintain spacing for heat dissipation. Tighten clamps shortly after assembly. Mounting structure. Isolate dissimilar metals. Avoid deformation during pile driving. Ensure accurate alignment. Civil works. Manage dust. Install fencing. Ensure proper drainage. Maintain site roads. Equipment enclosures. Seal unused glands. Maintain gaskets. Prevent water ingress. Environmental monitoring. Correct pyranometer placement. Avoid shading. Ensure accurate PR calculations. Cable management. Protect cables on edges. Proper labeling. Maintain bending radius. Adequate burial depth. Signage and labels. Safety labels. Equipment ID. Emergency contacts. Electrical safety. Follow IEC standards. Use DC overcurrent protection. Install SPDs as per IEC 60364. Maintain separate earthing for LA. In this module, we explored the full process of PV installation and operations. From understanding system components to selecting high-quality equipment, designing off-grid systems and mini-grids, ensuring safety, and following best installation practices. By mastering these concepts, you contribute to building reliable, efficient, and long-lasting solar power systems that support global clean energy goals. Thanks for going through and reading. Don't forget to like, share, and subscribe for more solar insights from I-SED Academy. Please go to I-SED Academy platform for detailed learning about solar technologies.